Hey, I'm Mike from HACKADAY. We're at the 2016 Bay Area Maker Faire, and I ran into Pierce Nichols with a really amazing project. What are you showing off today?
So we're working on building a round-the-world autonomous boat. What we brought here today was a couple of our test beds that we're working on, so we can actually learn how to build an autonomous boat capable of going around the world.
That's awesome. Is there a name for the project?
Our overall name so far has been Hackerboat, which is the name of, which is derived from the name of the hackerspace we've been based out of so far. It's Hackerboat Labs in Seattle.
And so what are the challenges to building a robot boat that can go around the world?
Durability is the biggest one by far. So a lot of people have tried to send autonomous boats across ocean basins. And if you look at, and if you read, their blogs and the accounts of what's happened to them, often, the boat will take off and it'll run well for like 2 or 3 weeks, and then it'll run badly for a little while, and then it'll vanish.
Sure.
And this happens over and over and over again. And, the reasons vary by the boat, but what it boils down to is the ocean's a super harsh environment.
Sure.
And building a boat that'll actually survive it is a tough engineering challenge.
So this one over here looks like, is this a model or is this actual size?
So this is a test boat.
Okay.
It's to prove out our actual propulsion system that we're using for the around the world boat. As such, it's 3.5 feet. Our around the world boat is going to be 20 to 25 feet. And, with sails scaled up appropriately.
Yeah, so how tall would a full-size sail be?
We'd be looking about 25 to 30 feet.
And so, to me, looking at this, intuitively, it looks like it's going to get flipped over. How do you safeguard against that?
So, there's a part that's actually not installed right now, and that's the keel. For this boat, the keel hangs a couple of kilos of iron ballast about 30 centimeters below the bottom of the boat. Unfortunately, with it sitting on the table, that would mean we'd have to cut a hole in the table, and it's not a great table, but I don't want to cut a hole in it.
Sure.
So we just have it strapped to the table right now, instead of with the ballast installed.
So the kayak behind us, is this a full-size or is this still a scaled-down model?
This is still small. This is only about 17 feet long rather than the 20 to 25 we're targeting. What we built this boat for is testing our systems and our sensors. Okay. And it's closer to actual size for a couple of reasons. First off, because we were able to get the hull cheap. It's an old and very much abused kayak. And second of all, having it close to full size means we can do things like we can mount full-size stereoscopic cameras on it that are about the size that the full-size boat will take. In this case, they're about 1 meter baseline,
Sure.
which means that we get a depth map out to 200 or 300 meters away.
Cool.
Cool.
And so I think you were saying the idea isn't to just have one of these, you're going to have lots of them.
Yeah, so the initial idea is to get all the way around the marble. Longer term, we're looking at deploying significant numbers of them in order that we can do ocean sensing of various kinds. And really what we're looking to do is create a platform for doing ocean sensing. So we take customers' sensors or mission pallets or whatever, we bolt them into our boat in whatever quantity they want to hire, and we send them out to do their thing.
Oh, man, that sounds wild. So if people want to learn more about Hackerboat, where can they go?
So right now our only web presence is actually on hackaday.io.
Nice.
Look for Hackerboat. Unfortunately, that doesn't Google because, unbeknownst to us when we named it, it's also the name of a yacht company that's been around for a while.
Well, I'm sure a buzzwordy title will come along, but for now, Hackerboat works for me.
Yep. Thank you very much.
Thanks for